Demetrius, how could you put me like right after Mate? I can't top that.
I just wanted to get us all on the same screen for a moment because we're all going to be at this LLM Avalanche event in 2 weeks. So if you're in San Francisco, I'm going to say it again. I hope to see you there at the LLM Avalanche event. I'm flying to San Francisco specifically for that. It's going to be a blast, and I'm going to get to meet both of you in person, face to face, for the first time after we've been hanging out virtually for the last like 3 years.
Yeah, should be fun. Yeah.
Yeah, I can't wait to put the picture with you both on Instagram.
There we go. Matt Tate, thank you so much for talking to us about DSP and all this great knowledge. I look forward to seeing you in a few weeks, man.
Yeah. Thanks a lot.
See ya. So, Chip.
Hey, oh my God, I'm still very nervous. Whoa.
I know that it's gonna be incredible. Do not feel nervous at all. I just want to say that every time I like try to write something about something that's happening in ML ops, whether that's like real-time streaming or now this report, it feels like you beat me to the punch, and then I see what you write, and then I go, oh, how am I supposed to even do anything now? This is so good. So if people do not follow Chip's blog, we're gonna leave a link to that in the chat because I imagine there's only like 2 people on here that do not know who you are and do not follow your blog. It is so good and so refreshing whenever you drop a so like in-depth research really is what you do, and the way you can put it all together and explain it, I love it. So that is my
Demetrius, I already like you. You don't have to say so many nice things about me.
So that's what I'm gonna do right now. I'm gonna leave it at that, and I'm gonna let you jump on and give your full talk, and then
I have
I'll be
some
back in like,
questions. How
yeah.
do I see the chat from the audience?
So it is on the. I'll post the link for you on the behind the scenes stuff so that you can just jump in, and then people can talk to you through that. And also, I think so. I did not do your Slido thing yet, but I'm going to, and I'll let you know when that's ready. I will try and do that right now as you're talking. So Chip's got a little interactivity with her talk, and if I can do my part, then it's gonna be cool. And so
Yeah,
I'll
no,
let you
don't
know.
worry. It's not a big part. I usually love like talking with the audience and see like questions and stuff. Okay, but cool. Don't worry about the Slido. Thank you so much, Demetrius.
I'll text you when it's ready. Don't worry. I'm gonna make it happen. This is all me. I'll see you in like 20 minutes, 25 minutes, however long it takes.
Cool,
All right?
cool.
See ya.
Yeah, thank you. See ya. Okay, so can you all see me? Cool. Wow. That's an interesting experience not being able to see the audience. But hi, my name is Chip. Thank you, Demetrius, for this very warm welcome. And I love the community. You guys are amazing. So much more organized than our community. So we do run a little bit of like MLOps Discord community. So here's a link if you want to check it out. So the talk today is a little bit different from the original title. So I thought that would be more fun to just go over like open challenges because everything is changing so fast. So I just worried it's like everything I talk, if I show people like okay, building applications gonna go outdated. So I'm just trying to like focus on some of the few challenges that I see today. So these are ranked by like how I perceive as important, and I would love to hear from everyone's like how you guys are thinking about the space. So challenge one is like consistency. So whenever we use an applications, users expect some certain level of consistency. And the second aspect, consistency, is just like how to ensure downstream applications can run without breaking. Because like a lot of time when we use LLM, we don't just use LLM and get the response back, but we might want to process the response for downstream applications. So I think this is like pretty well-known problem at this point. So like for LM, for because of its stochastic nature, sometimes you can have the same input and different output, and you can enforce deterministic determini- determinism by saying something like set temperature is equal to 0. However, it doesn't really fix the cases when you can just have a small changes in the input, and it can lead to like very big output changes. For example, here is just I'm just using ChatGPT, very simple prompt. You like get the review score from like 1 to 5, and you can see just like it just changed the output a little bit, it's changed input a little bit, and the output is like completely different. And it's just like part of the stochastic nature of LLM. And of course, there's a part about like how we might use downstream applications on top of LM. And I was using this, and I want to like use LM to like generate a score, and I want to use an application to parse the score. But then I realized that this is really hard because there's no way to enforce the output schema of LMs. The second challenge is hallucinations, and I would say I see that as the biggest one of the biggest challenges that prevent companies from adopting LLM. So this is very interesting. So like there's a teacher who used ChatGPT. So like he used ChatGPT to write essay and then assigned his student to correct the essay. And they found out that like every single one of these essays have had hallucinated informations. So this is this is very dangerous for on the task where factuality like is very important. So one example is that one example is of course like on the tasks that require legal HR, a lot of contract processing, but also like on the tasks that involve some kind of like code writing. So for example, today LM actually perform very poorly on text to SQL generations. So here's a BERT SQL leaderboard, and you can see that the best model achieved like under 50% accuracy, which is like very, very bad. So there are multiple reasons like why there are we don't really know. I don't. I haven't met anyone who knows for sure why LMs hallucinate, but there are hypotheses. So one by DeepMinder said that like it's due to the models like the understanding of the cause and effect of their actions. And another hypothesis that pushed by several people from OpenAI is that this due to the mismatch between LM internal knowledge and the label sorry, this is like early event for me, so I haven't had enough coffee and I'm just like tongue twisted all the time. Okay, so between the LM internal knowledge and the labeler's internal knowledge. So imagine in the face of like when we try to fine tune the model, and you will want to ask a labeler to annotate the answer, for example, question answer, and the labelers might know things that the model doesn't know. So that like so if the labeler if we teach the model to like generate responses based on the information that the labeler knows, but the model doesn't know. So we're essentially teaching the model to hallucinate, and it's just like really hard to correct. And like we can go actually I go more in my blog post, but we probably do not have time to unpack this in this talk. But feel free to reach out if you want to chat more about this. Another challenge is privacy. So it's challenging in both like whether you build or buy. So say if you want to build your own chat, say like if you want to let the users talk to your data, how to ensure that the chatbot doesn't accidentally reveal sensitive information. So here's an example. I didn't update it to the new one. But it's there is like it's a spot to jailbreak ChatGPT, and you can see a lot of examples like that. So companies like companies that provide APIs, like OpenAI or other companies, spend a lot of effort into making sure that like the answers do not accidentally reveal informations. But like if you build a chatbot in-house, that is your responsibility. Need to make sure that you don't just accidentally reveal some PII. And then if you buy, then you have the whole challenge of like you have to depend on the AI providers compliance. So right now OpenAI like retains the data for 30 days, and it really depends on the industry whether it's acceptable to you or not. Another big challenge is context length. So I think we have a lot of discussions on like whether prompt engineering is gonna go away. So I would say, as a way sees it, is that like I don't think that context learning will ever go away, but there will certainly be there's certain hacks around prompt engineering that might not last. So the reason why context learning will never go away is because it's like a lot of conversations or questions as like very context dependent. So it's a very interesting study on the paper like situated QA, and they found it's like roughly like 16.5% of on the questions like require context. So for example, it might be asking just like what is the best restaurant, Chinese restaurant. So it's the context here might be very much dependent on like the locations, like where you're asking, is it in the world, in the US or in China, and like or if there's no context provided, what is the assumed context? Like what could be the default context for the questions. So this is very common in like use cases like document processing, summarizations, any use cases that involves like genes or proteins. So here's a you can see on the table there's some study on like the average, so 90th percentile input length, and you can see that like for some use cases the context length can be like up to like hundreds of thousands of tokens. And I noticed there have been like a lot of studies to like making the model can work with long context length. However, there's still like questions about like, okay, a model might be able to take in 100,000 tokens as the input length, but how efficiently can that model use all these tokens? I think this is like still a open question. One thing that's like generative AI is that I'm really glad about is just like ChatGPT made everyone realize the importance of data drift, because we'll be asking question, it was like, oh, because our knowledge cutoff is like blah blah blah, that's why I cannot answer the questions. So so also the same paper for synthetic keyword, I think it's a really good paper. And the good showing is that like for the models that trained on data collected in the past, just fail to generalize to answering questions asked in the present, even when you provide the evidence in the context. So like the performance drop is about like 15%. And this is quite significant. And here I think we have a pretty interesting breakdown of like what kind of like how quickly things go outdated. So like from like 1 week, 6 months, 2 years, 50 years. Here's some example. So this leads us to the next challenge, which is like, so say like the model has drifted, the data have drifted because the world changes, right? And now we might have like the same model, new data, or another case when like there might be a new model architectures, a new tuning technique. So transformer architecture has been incredibly sticky, but how long is this gonna last? So in many cases, we're gonna have like new models. So imagine that you have a company that you are using a lot of prompts, and the prompts have been tested to work with the current model. So like if you swap out the model underneath, then how often, like how well can the prompt still work on the new model? And I think there's very little study around this area right now. And actually, it's pretty funny. I just saw, I think Hacker News a couple of days ago on the front page, so we were discussing this. Um, so another very big challenge is also like LLM on the edge. So I see that's like there are like a lot of use cases when like users don't want to send data outside of the locations. For example, like in a lot of we talk to a lot of healthcare companies who just have like a lot of different like medical centers, and you just like either because of the data is sensitive, you don't want to send a patient data, or just because of the many of these medical centers is located in the regions where the internet is not reliable. So like in the life and death situation, you just don't want to like make somebody else, someone's life depend on whether the internet's gonna go through or not. Also like autonomous vehicles, there are going to be a lot of cars on the road, and like each car may have its own like compute compute engines to be able to like run their own model, and so I drive through voice bot. And I do think that's like there's a very big dream that I see a lot of startups are trying to do, is like or build everyone a personal ChatGPT, so it can be trained on their own data and can run on their own MacBook. And the dream here is that if the LM runs on their own MacBooks, then you're not worried about like sharing with this or sensitive information, and it can be more open and it can be more helpful to you. However, for this, there would be a lot of like challenges as well. So first thing is like this model one has to be able to like run do inference on device. So the device has to be powerful enough to support the model's inference, and then maybe you have some like a lot of techniques to like quantize or make the model run inference faster on the device. So another challenge is also like on term of like training. So it's one thing to do inference on device, but like how would you like update the model, because we have established that the world just changes. So say like maybe there's a newer model training technique comes out, and it can improve the model performance. Then how would we update each model on device. So on device trainings is like today's still bottleneck, but it really depends on the model size and model architecture. But a lot of it is like still bottlenecked by compute and memory and technology, like for continual learning and evaluations. And then if you train on servers and you go into like if you don't want to do inference on server due to like sensitivity, then how would you then you put it on into the same problem if you want to send data back to a server somewhere to train the model. And another thing is just like maybe like I have used a model, I have fine tuned it on a lot of my like data on device. So like if I somehow like update the model, the base model, how can if I have a new base model, how can I still like update how I do still like continue fine tuning this new model on the data I have generated in the past. So I think there's a lot of I was at a panel recently and there was a questions on how is there a way to do like federated training, so learning, so that you can update a model on data on device without having to send the device back, and it's a very big challenge. So there's a question like choosing a model size. So I think it's related to on device because if the dream is to eventually run a model on device, so we probably need to think carefully about whether how big the model should be. And I think that there are a lot of factors to consider as well when considering a model size. So I've seen this like there's usually a sweet spot between like a model performance and cost. And of course, I would say this like this changes over time a lot. And also, I just want to bring up a point about counting model parameters. So today we just like assume it's like 5 billion parameter, 10 billion parameter, and it's just like said is as in like the number of parameters is the only thing that matters. But I think it's like highly variant. So first of all, it also depends on whether a model is sparse or not. So like say like 100 billion parameter sparse model is going to be very different from a 100 million billion parameter dense model. So I haven't seen a lot of research about sparse and dense model in LM, but I would be very interested in learning more about that. So another things that I haven't seen people talking about as much is the LMs for non-English languages. So you can probably guess by now, through so much of my tongue twisting in this talk, is that I'm not a native speaker. So I'm from Vietnam, and one of the first thing I tried with ChatGPT was to use it for Vietnamese, and it didn't perform well at all. So one thing is that like when I try to translate generative AI into Vietnamese, it's actually translated it into reproductive AI. So there are many examples of like it's not doing well. So here I think it's a very interesting paper. Actually, there have been several papers on the study of like LM's performance on standardized tasks, but in different languages. And you can see that like it doesn't perform well for a lot of non-English languages, especially for low resource languages. Another big challenge is a tokenization process. So here's a very interesting study by Yenny to show that the median token length for different languages on GPT-4, and you can see that like it's pretty bad for languages like for low resource languages like Burmese or Amharic. And so say like if the same for a given input, if the tokenizations that produce a lot of tokens that can affect both the latency and cost. So yeah, so I would be interested in seeing like how much of more cost and latency increase for different languages. Um, yeah, so a lot of APIs today charge people by the output token length. So like if a language just like have a lot of tokens, and the cost is clearly gonna be a lot higher. Another very interesting questions I have seen a lot of people discussing is the efficiency of chat as an interface, or more generally like a chat as a universal interface. I was meant for this to be more of a discussions, but I can't see you guys. So yeah, so so maybe answer in your head, which you prefer, search interface or chat interface. So I see that people have been complaining, telling me this like, oh, the chat is not very efficient, right? So like if you want something, you have to like, oh, make a small talk, no, maybe not make small talk, but like you have to give it context, and you have to like go back and forth to get exactly what you're looking for. Whereas for search, you have learned the DSL of search, and you can just like find exactly what you're looking for. So I think it's like this is I do agree that I do think that like chat is not efficient, but I do think that it's a very, very robust API. And the reason is just like for chat, you can just like type in anything, and you get back a response. It might not be a very helpful response, but you get back something. Okay, this is probably going on a tangent here.
Chip, sorry, I think the stream might have stopped. I don't know if people missed out on it. I'm gonna see. Oh, so yeah, where we last saw you was on challenge number 5, data drift. And I am going to start the stream up again just to make sure that we're all good. But sorry about that.
No
And
worry.
I'm now on my phone, so we may have to do some in a minute. And
Wait, is that my
so,
internet? Or what happened?
no, it's all on my side. Don't worry. It's my internet went out. All right, it works. We can see. We can see. We can see, and people are back. They're back online. Cool.
Oh my God, Vivo! I just said so many intelligent things on the spot. You just totally missed it.
No, no, don't worry. I think everybody said it was fine and they saw it all. Okay, it was just me that went out. Oh, I'm
Oh, okay.
overreacting, and so we're all good.
Oh
The chat is saying it was,
no.
yeah,
Just
it's
kidding. I
fine.
didn't say that many intelligent things.
Yeah, so they heard it, they appreciate it. I'm gonna get off the stage before I continue to look like an idiot. I will say though that the Slido is not going to happen because I need you to grant me access to that.
Okay.
But we can do that during Q&A, and then we can do the Slido. All right, see you later. Go ahead. Sorry to break the flow.
Yeah, no worries, no worries. Okay, so I think let's talk about like chat is not efficient, but it's very robust. You can take in pretty much any input and give you back some output, even if the output is not that helpful. So yeah, so sorry, I see some Slack messages like we'll see everything. That's great. Cool. So yeah, so I think about like the tangent I was going into is evolutions, and if you look back, it's like it's not. So we have been saying it's like it's a survival of the fittest. But I don't think like humans are actually optimized for being efficient. Humans are actually optimized to be robust, and I think like survival is not of the fittest. I feel like I probably do not have time to go into this in detail, or but basically, like there's a lot of discussion about like this is not what was very important is to have an interface that is robust. And I have seen actually so the discussion of chat as a universal interface is not new. It has been around, like you can see like this Dan Grover has great discussions back in 2015, because like in China and a lot of countries in Asia, people are very very familiar with chat as a universal interface, and they do everything in chat. And also like there's a few studies that I have seen. I can't name them because they are confidential, but basically people have studied like the how people prefer the search or the chat interface really depends on how much the users have been exposed to each interface. So for example, for a country where a lot of populations have not been exposed to like internet for a long time, they actually prefer the chat interface because it's just like feel more natural and easier to use. Okay, so the large challenge is big is a data bottleneck. So we have seen just like a lot of models use a ton of data, and it seems like there have been some study, for example, by DeepMind that shows that a lot of models, like a lot of data, is just still underutilized. So like the models still has a capacity to even learn from like even more data. So and we seem to be running out of like internet data. So this is very interesting study showing that the rate of training data set size growth is much faster than the rate of new data being generated. So at some point, I think this is marked as like 2026 that we will actually run out of publicly available data. And on top of that, like the internet is being rapidly populated with AI generated text. So if so for the future, if you crawl internet data to like train a new LLMs, it would likely be trained on like text generated by the existing um, LLMs. So yes, that's something like definitely to think about. So if anything that we have seen through generative AI is that data is very essential to any companies that want to leverage AI, and we have seen like over the last since AI came around, 70 years ago, there have been many hype cycles. So maybe today is like generative AI is a hype, but we do not know like in the future what is gonna be the next new hype. So one thing that consistent through all this is data. Like data is just very important. So we see that a lot of companies in the face of generative AI, the first thing they do is to like figure out the data story, like consolidate existing data across departments and sources. When I update like data terms of use, you can see like Stack Overflow and Reddit responded pretty fast, but like not fast enough. Like just maybe they could have done it like years ago. Or like put guardrails that are data quality and governance. So yes, that is pretty much it. And here is a summary of all these challenges. And do reach out if you have any questions. I'm on LinkedIn, Twitter. I'm also on Discord all the time, and I have a book. But yeah, that is for me.
Awesome. A lot of people were saying that they had your book and they loved it. And I wholeheartedly agree. I think it is amazing. And I always wonder how you're able to write so much and also run a company. It is amazing to me. It's super cool. So I think there's going to be some questions coming through in the chat. I don't want to cut you off because of my little interlude, and I
Yeah,
want to let people do it. Luckily, I learned the first time that we had this conference, there is a little bit of cushion now on the brakes, so we can have more flexibility when it comes to the timing. All right,
yeah.
so I can ask you some questions, and also in the meantime, do you want to give me access to that Slido and
Oh,
while you're answering the question?
I don't have a
Or
Slido.
no,
Uh,
no, sorry. You give me access to the
Slides.
document, yeah, the
Yeah,
slides. And also, people were asking about the slides and if the slides are going to be anywhere. So, yes, we are most definitely going to have the slides for
yeah,
everyone to check out. And we will throw those in the recording, right in the description of the recording once it's out.
yeah.
So while there are questions coming through, who's got questions in the chat? Feel free to. Oh, somebody's asking if there's going to be a next edition of the book.
Perhaps. Yeah.
Uh,
Oh my God, I was so sorry. I think this is a new talk. I got so nervous about going after mate that I was like couldn't sleep last night. I was like, oh, I need to come up with something. Yeah. Sorry for, and I
well,
was like, what happens when I don't get enough sleep is just do not speak very well. Somehow like on this like immigrant side in me just came out when I do not sleep. So
it was perfect. And that is funny, the idea of drinking coffee beforehand. The other thing is,
yeah,
I mean, you did mention in the talk, in the part um, that I was on for because I got kicked off and thought everyone got kicked off for a little bit and was afraid like, oh, the conference stopped. But I saw that you were talking about how there's not, what was it? There's not models that are useful in other languages, and especially like the languages that are less spoken or that have less speakers of the languages. It's much harder to find LLMs that are useful with
I
them.
think I want to correct that. So
Yeah,
so I think
um,
it's not proportional. So there are languages that have a lot of speakers, but they are not represented equally in the corpus of like training data. So for example, there are languages with like hundreds of millions of speakers, but they account for like what under 1% of like or like sorry like 0.0 some percent in like say common core corpus. So yeah.
I see. I
Yeah.
see. Okay, good. Well, should we get into some questions, Chip? You want to hear
Yeah.
what the chat has to say?
Yeah.
Um,
But then so just want to follow on the like non-English
yeah, yeah.
models.
Go, go, go.
Yes, I noticed like so I do this just like I think it's like I like to go on a tangent. I see this like the evolutions of like language model, right? So you start going from like what both architecture wise like methods wise. So we went from like counting method to like neural network. So we went from like single task to like multiple task, right? Like with like single task before we had one model to like do machine translations, another do sentiment analysis, and now we have like models that's generalized to like multiple tasks. And there's a center another access actually go from like a model for each language to like a model for like multiple languages. So I think it's very funny to say like a language model and not languages model. It's like language here is singular. As I was trying to write about like language modeling, and it's really hard to say, okay, this is a model to model language or like languages, because it's somehow it's like made everything is like one single language that LM can understand. So
Mm,
yeah, but it doesn't understand some language as well as other. And I see a lot of
mhm.
countries actually working really hard to build language models that work very well for that language for their language.
Yeah, it's super. See, somebody was asking if you know any projects that are going on in that field.
Oh, I think Japan is very big on that. I think Japan is like make it like a government priority. Vietnam. So I'm from Vietnam, so I'm more aware of the effort there. I think they're like if you're Vietnamese, you should certainly check out. Um, ping me. There have been a very big push both by companies and like open source community in Vietnam.
Hmm. And have you tried LLMs for annotating articles? What do you think about that? If you have,
Entertaining article. What does it mean?
yeah, like I think it's annotating data basically from articles, like newspaper articles or stuff like that.
Like to summarize articles or fact check.
I think it's for the actual like data labeling. That's what I understand from the question. But John
Oh yeah,
Roberts
like
asked the question. Feel free to uh, put more context around that if I'm not saying it correctly.
yeah. So you
Yeah,
mean
yeah.
like
Go ahead.
to like synthesize data? Is this about data synthesis?
Yeah, I think so. I guess from what I gather from the question, so this is the question word for word, and then I'll tell you how I interpret it, and then you can go ahead and interpret it
Yeah,
however you want to. Have you
yeah,
tried LLM for annotating articles? What do you think about that? And the way that I interpret it is that it's like you're using LLMs to data label for your data labeling for training later another model.
yeah. I think that's pretty common. I think like there's a whole. I think it's like knowledge distillation. There's a whole premise behind the alpaca, right? Like you use a large, better model to like generate output, and then you make smaller model to just like copy that behavior. So I think see that's a lot.
Cool.
I,
So now we've got some,
No, I think it's funny because I was talking to a friend about I was asking him like how do you think about the future of like prompt engineering? And he was like prompt engineering matters as long as human to human communication matters, right? Because it's just like for human to human communication sometimes we still need to put in a lot of context for like the other person to understand. So the same thing with prompt engineering is like the matter like putting in things so that like LM can understand.
awesome. So we have a panel coming up, but there are some incredible questions that are coming through the chat. Now it generally happens like that, right? It gets a little bit delayed and then people are typing. And so then it's a little bit even more delayed, but I want to ask these questions because they are awesome. Do you think that LLM developers are cooperating adequately with experts from other disciplines such as linguistics, sociology, and ethics?
That is like a very big question. So how would we measure that?
Yeah.
So I do think it's
They were asking me, not me.
I mean, like NLP is an example of like how different disciplines came together, right? Like linguistics and computational, science, computational scientist. So if you look at the history of like NLP, it is not, it's definitely like already like the merit of like statistics, computer scientist, and linguistics. So it's a very incredible, fascinating field, and I could see that like these adoptions in like other fields as well. So I think I'm very excited for like gene sequencing, right? People are treating it like language model, and I can see that's like if we can bring a lot of like life science scientists, it could be pretty cool.
Yeah, I completely agree. So there's all kinds of other incredible questions that came through the chat. And Chip, you have the link to the chat, I think, so you can jump over there. Also, Chip is in Slack, in the MLOps community Slack. And if anyone wants to ask any questions to her, just tag her in the community conference channel if you're in there and you want to start a thread. And I think that's it. Chip, I'll see you in a few weeks for the first time,
Oh
right?
my God, yes. I cannot wait for it. I don't know why, but like whenever I see Demetrius, you just seem so much fun. You just seem like a fun person to party.
Those are some
He's
big shoes
big,
to
yes,
fill.
yes.
I got lots of expectations. I don't like to keep it up here. Let's lower the bar, please.
Better start practicing the dance moves. Okay, see ya.
Yeah. All right. See you, Chip. Thanks
Thank
for
you.
this. This was awesome.